Bismillahirrahmanirrahim. In this video, we'll talk about instantaneous powers due to sinusoidal excitation, and we'll also solve practice problem 11.1. So we have a series RL circuit here, and the input is now a sinusoidal signal Vm cos omega t. Now, since the circuit is in steady state, if it is not mentioned, we'll assume it to be in steady state. And what does steady state mean? Let's clarify. From this diagram, we have learned earlier that in case of a step response, if the input was 40 volt earlier and then suddenly it is increased to 100 volt, then the capacitor or the inductor circuit will take time to charge. So this period where it was constant is called the steady state period. This period when it is again constant is also called a steady state period. But when this is changing, this is called the transient state period. Now if the circuit behaves like a transient state period, then we have to our solution will be e raised to the power something. But if it is steady state, then we'll just we can use the normal Ohm's law formula, and for that we can convert the circuit into phasor circuit, or solve it with the phasor circuit or phasor domain. Now, since voltage is given as Vm cos omega t, so we are assuming that the current will be Im cos omega t plus phi, some angle phi, where I is Vm over Z total. So this is the magnitude Vm divided by the impedance of the circuit will give us the current. And so It will become, now Vm as Vm, and Z total is from here is the amplitude of the two added, so R square plus j omega L whole square and under root. So this I am sure you have learned earlier. And the phase angle phi is given by minus 10 inverse omega L over R. And if you don't recall, you just see page number 381 of your book for explanation. Now the instantaneous power delivered to the entire circuit will be P is equal to V times I. Now remember, we had mentioned earlier also that whenever we write T, that means it is instantaneous voltage or instantaneous current or instantaneous power. So P is equal to V into I, and we have learned that it is Vm cos omega t, and I will be Im cos omega t plus phi, because there is a phase difference between voltage and current since the circuit is inductive. And from here we can write Vm Im cos omega t plus phi into cos omega t. And some mathematical manipulation. This is the formula that we can use. Then it will be Vm Im over 2 cos 2 omega t plus phi plus cos phi. So once we are adding the two and other we are subtracting the two. So cos omega t plus phi, omega t plus phi plus omega t will make it 2 omega t plus phi, and omega t plus phi minus omega t will make it cos phi. So, and finally we are getting these two terms. Now note that this term does not have a t with it. That means this is independent of the time, or this is constant, and this is depending on time. Okay, now let's see the practice problem. The practice problem says that a current source of 12 cos omega 2000 t ampere, a 200 ohm resistor and a 0H inductors are in parallel. So the circuit could be drawn like this. We have a resistor and an inductor in parallel, and this is the current source which is supplying the circuit. Assume steady state condition. So we have discussed earlier also that whenever it is steady state condition, we can apply the phasors form to solve the circuit. At t is equal to 1 milliseconds, we have to find the power being absorbed by the resistor, inductor and the source. Okay, so if we compare the given current, this one, with the standard formula Im cos omega t plus phi, then we get to conclusion that Im is equal to 12 and omega is equal to 2000. So omega is equal to 2000 radians per second. Now, as we mentioned that in case of a steady state condition, we can use the phasor domain, so we convert this into phasor, and I hope you know this, the magnitude 12, and since there is angle 0, so we write it 12 angle 0. And also we convert the inductor here, 0.2 Henry, so inductor can be written as j omega L. So j omega we have found out from here is to be 2000, this 2000 radians, 2000 multiplied by L, so the end result is j 400. And now let's draw the phasor circuit. So this circuit converted into phasor form, this becomes 12 angle 0, resistor remains same, and the inductor 0.2 Henry will now become j 400. And now to find the current, let's first of all find current IR. By KCL we can find this, the total current divided by the total impedance, so 200 plus j 400 and multiplied by opposite arms. Since we are trying to find for this arm, so we will multiply by the opposite arm j 400. And solving this, j 400 can be written as 400 angle 90 degree, and this you can solve by your calculator, converting into polar form, and then dividing or simplifying, we get this answer. So this is IR, and similarly we can find IL, again total current divided by total impedance multiplied by opposite arm. So now we are finding this, so we'll multiply by 200, and the answer is as shown here. So we have found the two currents. Okay, so we had these two currents in phasor form. Now we'll try to find the two voltages in phasor form. So we know that VR is IR into R, so voltage here. So we have IR multiplied by R200. So this is the voltage VR. Now since they are in parallel, therefore VR should also be equal to VL. So we can directly write that VR is equal to VL is equal to V. Now those of you who don't believe, you can solve this and you will find out that is the same answer. So VR is equal to VL. So we have found the two phasor currents and we have found two phasor voltages. And now we have to, since we have to find at t is equal to 1 millisecond, so now time is coming back. T is equal to 1 millisecond, we have to find the power being absorbed, and therefore now we convert back or move back into time domain. From phasor domain we move back into time domain. And so now IR, this one, will become 1073 cosine 2000 omega t plus we plug in this angle. So this is IR, and similarly VR from here can be written as 2146 cosine 2000 t plus this angle. And also IL from here 5.367 cosine 2000 omega t, and since angle here is negative 63, so it will be negative 63, and VL remains same as VR, so we can just copy this. So we have found the 4 terms in time domain now, and so now we had found these 4 terms, the 2 currents and 2 voltages. Now let's try to find the instantaneous power. So we know that power is V into I. So instantaneous power across a resistor is VR times IR, and plugging in the values from here and solving. Now since these 2 terms are same, so we write as cos square. Now at 1 millisecond, that is when the power is desired, therefore t will be replaced by 1 millisecond. So the t becomes 10 raised to the power minus 3. Solving this will become 2, others remain same. Now here is a caution, this 2 is in radians and this is in degree, so we can't add them. We have to convert either this degree into this radian into degree, or we convert this degree into radians. Now since most of our calculators are generally set for degrees, therefore it is better that we convert this into degree, and the procedure is that we multiply 2 by 180 degree and divide it by pi, and so this will become 114.6 degree plus 26.6 degree makes it 141.4 degree, and then finding the value of cos 141.4, it is minus 0.78. This is square, so we put a square over this, and then multiplying we get the answer of 14.63 kilowatt. Now this is the power consumed by the resistor. Exactly similar way we find the power consumed by the inductor, so VLT into IT, and plugging in these values and solving in exactly same manner. Now since these 2 are different, so we'll keep them separate, and we can find the power to be minus 5.636 kilowatt. I hope we can go through this and find. Now we have got the 2 powers, therefore the total power, or the power by the source, is the sum of the 2, and 14.6 from here plus minus 5.63 from here. So this is 8.41 kilowatt is the power supplied by the source. Now since in the book he has asked power absorbed by the source, therefore power absorbed will be negative of power supplied, so we just put in a negative sign. So now this is the answer given in the book, which is very close except for the calculating error sum. So I hope this gives you an idea as to how to solve this type of a problem. Thank you.